Carboxylic acids are important compounds, are important functional groups in nature and in science as a whole, and particularly in chemistry. An important property of carboxylic acids is actually their acidity. So why are carboxylic acids are acidic? Why are they acidic? Let's draw the structure of carboxylic acid. So this is a general structure for carboxylic acid or carboxylic acids. Now, carboxylic acids have a carbonyl group, a carbon-oxygen double bond, and OH group. This hydrogen, which is bonded to oxygen, is actually acidic for one reason, is inductive effect. The inductive withdrawal, oxygen being more electronegative than hydrogen, therefore it would withdraw electrons toward itself in that bond. But for carboxylic acids to be acids, or for them to have this term acids in their title, there must be something special with their acidity. And in general, of course, in chemistry, an acid or a substance, for a substance to be acidic, its conjugate base must be stable or stabilized. And when we talk about stability in chemistry, we talk about electronic effects. And in that regard, of course, we mean implicitly inductive effect and resonance. So let's draw the conjugate base of carboxylic acids, or when carboxylic acids lose this proton to a base. If you treat a carboxylic acid with a certain base, of course, with an appropriate strength, you get their conjugate base, okay, which is called or described as carboxylate. So this is a carboxylic acid, this is a carboxylate. So the carboxylate ions, okay, or carboxylates are conjugate bases of carboxylic acids, which are formed when carboxylic acids lose this hydrogen in the form of a proton to a base. This conjugate base, or this carboxylate ion, must be stable, and it must be stabilized by either inductive effect or resonance, or even by both, for carboxylic acids to be acidic. If this is not stable, therefore they would not be acidic to start with, and obviously they would not be entitled to have this acids, if you like, in their name. Now, if you look at this carboxylate ion, you can see that this can actually be stabilized by resonance, in addition to the existing inductive effect on the negatively charged oxygen. Oxygen can tolerate the negative charge because it's an electronegative atom, so therefore there is inductive effect. In addition to this, there is also resonance. You can take one of these lone pairs on the negatively charged oxygen to make a double bond between oxygen and this carbon, and simultaneously that carbon-oxygen bond must be broken in order to release, or as a result of it, electrons will then be released on oxygen. If we do that, then we get another resonance form for that carboxylate, which is this one. So that's another resonance form for the resonance stabilization, if you like, of this carboxylate ion, or the carboxylate unit. This resonance stabilization delocalizes electrons, delocalizes the charge, stabilizing the conjugate base, and therefore acidifying, if you like, the original substance, or the original material, or the original substance will then be acidic if its conjugate base is stabilized, and in this case it's stabilized by resonance. So this is resonance stabilization. Electrons and the negative charge are delocalized. Therefore, the conjugate base, which is the carboxylate, is stabilized. If the conjugate base is stabilized, then the original substance can behave as an acid So this is exactly why carboxylic acids are acidic. That's because their carboxylates are stabilized by resonance in addition to the already existing inductive effect on nitrogen. That's because it is an electronegative atom.